All right, so in the last video, I talked about wire bonding and kind of talked about different types of packages. I didn't talk about these acronyms, but they're just acronyms for the type of package. DIP is dual inline package. QFN stands for quad flat no lead. So you can see there's no leg coming off. That's the legs are also called leads. So quad flat no lead is QFN. SOIC I think is small outline integrated circuit, shrink outline integrated circuit, or something to that effect. It's not really important. Let me just Google it just so that I can. Let me see what it says. Small outline integrated circuit. Okay, so that's what SOIC stands for. And so each one of these, like I said, it's now ready after it's been, the chip itself. So the chip has been laid out, it's been packaged and wire bonded, and now the chip is ready to be interfaced with. We need to put it on a printed circuit board so that it can actually, the signals can then be routed out to where we can interface with them, where we can connect a power supply, or we can, say these two need a resistor between them. We can connect that on our printed circuit board. Okay, so how do we do that? Well, each package has an associated footprint. It's called the footprint. And I'm going to go to the next slide so you can see that. These are the footprints for the packages on the previous page. And you can kind of see, right, if I were to take my 8 DIP, my dual inline package here, which has 8 legs, I could plop it right here on a printed circuit board, just like this. I would put it right here, and then each of the legs, let me try and get like a gray color, would come out and go into the PCB just like that. And then you would solder it, and then from there, once you solder that, now these legs can go off into my circuit board and connect elsewhere. I can make connections to whatever I need to make connections to on my board. This green square here represents my board, right? That's how it works. So I have my chip in here again, wire bonded out. Let me go back to my yellow, to these legs. The wire bonds are going out to the legs. The legs go into the PCB or the circuit board, and then the circuit board traces go out to wherever we need them to go, and that is how we interface with these chips. Again, that's just the dual inline package, the DIP 8. I've got the 16 QFN here. You can see that there are 16 legs, and they need some platform to be soldered to, basically, and that's exactly what we're looking at here. There's 16 of them, and then the big ground pad in the middle, and then the SOIC 20. SOIC 20 has 10 legs on one side and 10 on the other, and it kind of needs a little platform to be soldered to, and that's exactly what we get here. And again, I would go ahead, for example, on this guy, I would put my chip would get placed right here. My chip would get placed right here. My leads would get soldered right down to each of these pads, so on and so forth. And then I would route these signals on my board out to wherever I need them to go, and connect to other components, other integrated circuits, and so on. Okay, so these are footprints. Again, the footprint is just basically like the LAN. It's also called the LAN pattern. Sometimes it's where we're going to place the chip on our circuit board. And now I'm going to show you a circuit board before and after it's been assembled. So on this circuit board, I'm looking at an Arduino Uno. This is a very popular embedded systems circuit board. And you can see that there's no components on this board right now. It's only the pads and the holes where the components are going to go, okay? And so right here, I can see a pad, a footprint for a capacitor. There's 2 pads there, and we can see that we could place a little capacitor right here. I can also see a surface mount 8-pin package there. I can see a surface mount 8-pin package here. I can see this right here is a 28-pin integrated circuit. I think it's a DIP 28. You can see that there would be 14 legs on one side, 7, 8, 9, 10, 11, 12, 13, 14. And then on the other side, the same. There's all kinds of different footprints here. This is another integrated circuit. This one looks like it's a 32 pin. You've got 8 by 8 by 8 by 8. some and then there's all kinds of other types of components that we can see on here that we don't necessarily need to talk about. But that is what's going on the pre-assembled board. There's no parts. And then when we look at the assembled board, we can spot all kinds of different components and their footprints. We've got some LEDs on here. All of these guys are LEDs. We've got our DIP28 microcontroller. This is an integrated circuit again. Just to give it one more push. I have my integrated circuit somewhere inside of here. I've got all my wire bonds going to this chip just like this on the inside and so on the other side. And then that goes out into my circuit board, and then these signals, you can see them, they come from the pads and they go into the, oh, that's a bad color. They come from the pad and they go into the board somewhere. Come from the pad and they go into the board somewhere. You can see them. Same with this one. This one, you can see the connections on the PCB, right? And then this is a button. You've got a couple. This is a surface mount resistor, surface mount capacitors, like what we showed. Another surface mount resistor there. These are resistors. This is a capacitor. I'm pretty sure this is a diode. These are also larger surface mount electrolytic capacitors. Capacitor here. Okay, so these are printed circuit boards. Again, this is the pre-assembled state where we just see the footprints, and then this is after it's been assembled and all the components have actually been soldered onto the board. There's another integrated circuit here that I just noticed. And this is a power connector. This is a USB connector. So this is all the essence of electronics. This stuff really excites me. This is where everything comes to life. You know, all the stuff that we learned all semester long, where we're talking about components and currents, it all comes together in real life in this form on printed circuit boards with integrated circuits and passive components and so on. Okay, so I'm going to go ahead and end this video right here. And in the next video and the next couple of videos, I'm going to talk about assembly and manufacturing. And we're going to call it. That will be the end of the EE220 lectures. So I'm super excited to go ahead and end this video. And we're going to move on to assembly and manufacturing.